Welcome to my channel. In this today's video, we are going to solve the two properties of DTFT. In the previous video, we discussed one property and proof, that is a linearity property. Okay. So in this video, we are going to state and prove the two property. One is time shifting property, another one is frequency shifting property. Okay. So this time shifting and frequency shifting is a very important property. In some time, the question is that mentioning, if they are mentioning state and prove the following properties of DTFT, means this time shifting, frequency shifting is a repeated question only. Okay, so you see this time shifting is especially asked in 11, 12, 13 and 19. Okay, if they are asking state and prove any four property, mean you can write any four. Okay, so you must study this property. Okay, and using this property I solved some more problems also in the previous videos. Okay, so first we define this property. What does time shifting means? So already we discussed the time shifting in Fourier transform and Laplace transform. Okay, so in a similar way we are going to prove the time shifting property for this DTFT in this video. Okay, if you see, in order to state that one, first we are taking one signal x of n. So we know that the DTFT of the signal x of n is, we can written as a capital X of e power j omega. Okay, then the time shifted signal by the amount k. Okay, this signal x of n we may shift to the right side by some amount k, means that signal it can be written as x of n minus k. Okay, so we studied this time shifting, time advancing, time delaying, in that is the operations on the signal in the first unit. Okay, so in the first unit we solved so many problems, the operations on the signal. Okay, so if you want to study, means in the playlist you check operations on the signal, we solved 4 to 5 problems. Okay, so the time shifted signal by the amount k, it can be written as x of n minus k. So the DTFT of this time shifted signal x of n minus k is that the x of e power j omega answer multiplied with one term, it is e power minus j omega k, where k is the amount of shift. This is the property. Okay, so we are going to prove this time shifting property. So in order to prove this property, so first we are going to take the DTFT formula, our known DTFT formula. So what is the DTFT of the time domain signal x of n? The formula is that summation n equal to minus infinity to infinity x of n e power minus j omega n. Okay, now what is our aim? Our aim is to prove the DTFT of the time shifted signal x of n minus 1 as this. Okay, so therefore the DTFT of x of n minus k, it can be written as summation. So instead of x of n, that is the DTFT of x of n, means here x of n. Now we are going to find the DTFT of x of n minus k. So instead of x of n, we have to put x of n minus k into e power minus j omega n. Okay, and so you see in this formula, so here instead of the variable n, the variable n is shifted by some amount k. Okay, so that's why we are going to convert this shifted variable into the new variable. Okay, so that's why, so in the same procedure we applied in the second unit Fourier transform and Laplace transform. Okay, the same. Then next in the Z transform also, in the properties of Z transform also, we are going to apply the same procedure. Okay, that is what is the difference between DTFT and Z transform? Means instead of this e power minus j omega, here in that Z is there. Okay, it is a only different. So we are going to convert this n minus k as some new variable. So let n minus k, we have to assume as some new variable m. Okay, so if n minus k is a m, means, so what is n? The n can be written as m plus k. Okay, and the limits are, if n is the old variable n is minus infinity, means what is the new variable m? M is also minus infinity, that is minus infinity minus k. So if you are adding some minus infinity to some minimum 1, 2, means that answer is not changing. So minus infinity only. Similarly, n equal to plus infinity means m is also infinity. Okay, so we have to substitute these assumptions in a above equation. So we got summation. So instead of the variable n, we have to put the new variable m. Okay. So that's why m equal to minus infinity to infinity. In the place of n minus k, we have to put the new variable m. So x of m into e power minus j omega into, instead of n, we have to put m plus k. Okay. So that's all. So just you substitute these two value in the above equation. So now you see e power minus j omega m plus k. So you expand, you split as a 2e power term. So e power minus j omega m into e power minus j omega k. Okay, so you see summation m equal to minus infinity to infinity x of m e power minus j omega m. So what is this term? So this term is exactly resemblance to the DTFT formula. So you see DTFT of the signal x of n is summation n equal to minus infinity to infinity x of n e power minus j omega n. Instead of the variable small n, here the variable m is there. So this is the, what is this formula? So this formula, it gives the DTFT of the time domain signal x. So that's why, what is this one? This summation, it can be written as capital X of e power j omega. Okay. So multiplied with, what is the remaining thing? E power minus j omega k. Okay. So we proved. So the DTFT of x of n minus k is the original, that is the Fourier transform of the original signal x of n multiplied with e power minus j omega k, where k is the amount of shift. Okay. So this is the time shifting property. So from the above, we can say that the time shifting by k does not change its amplitude spectrum. Okay. So if the time shifted signal, if you are drawing the spectrum, okay, amplitude spectrum and the phase spectrum means the amplitude spectrum of this x of n minus k is exactly same as that of the x of n. So what is the difference means? There is a change in the phase spectrum. The phase spectrum is shifted by the amount minus omega k. That is the difference. Okay. So similarly, so you see this is the x of n minus k. What is x of n minus k? Time shifted signal to the left, to the right side. That is time delayed. X of n minus some value means it is a delayed signal, time delayed signal. So the time delayed signal, the DTFT answer is the original transform multiplied with e power minus j omega k. Similarly, if you want to find the DTFT of x of n plus k, what is x of n plus k? It is a time advanced version. Advanced version means the x of n shifted to the left side, negative axis. It is said to be the x of n plus k. So the DTFT of this time advanced signal is that the x of e power j omega multiplied with e power plus j omega. Okay, so here minus k means here e power minus j omega k. So here n plus k means the same x of e power j omega multiplied with e power j omega k. Okay, so this is said to be the time shifting property. Okay, so where we have to use this time shifting property means, for example, you see, find the Fourier transform, that is the DTFT, simply we are calling it as a Fourier transform. Fourier transform of u of n minus 2. What is u of n minus 2? U of n is the unit step signal. U of n minus 2 is a time shifted unit step signal. Okay. So in order to solve this problem, so we may use ordinary method also. Okay. So we posted this problem, okay, u of n minus k problem in the previous videos. Okay. But now this problem, so we may solve in a single step using this time shifting property. Okay. So in order to solve this one, so first, what is the base signal u of n? Okay. So you know the Fourier transform of unit step function is that 1 divided by 1 minus e power minus j omega. Okay. We solved this problem. Okay. You just remember some of the standard signal, the answer you just remember. Del of n means the answer is 1. For any transform, for impulse signal, the answer is 1. Similarly, unit step signal means the Fourier transform answer is that 1 by 1 minus e power minus j omega. Okay. Then according to this time shifting property, u of n minus 2. So u of n minus 2 means that is x of n minus k. What is this k? K is the amount of shift. So what is the value k here? 2. Okay. So if the amount of shift is 2 means the Fourier transform of this signal is that the original transform 1 by 1 minus e power minus j omega multiplied with e power minus j omega k, where k is the amount of shift. Here, which one is the amount of shift? 2. So e power minus j omega 2. This is the answer. Okay, so this is the use of properties. Okay, using property, we can solve the problem in a single step. Okay, that is the use of the properties. Okay, similarly, if the question is obtain the Fourier transform of u of n plus 2 means what is the answer? 1 by 1 minus e power minus j omega multiplied with e power plus j omega 2. Okay, that is the answer. Okay, so this is the time shifting property. So we solved some problems using this time shifting property in the previous videos, you just refer. Okay, then the next property is that frequency shifting. Okay, so this property is exactly reverse as that of the time shifting property. That is, time shifting means here the signal x of n, okay, x of n is a time domain signal. This time domain signal is shifted by some amount. Okay, means what is the effect in the frequency domain we studied. So the frequency shifting means in the frequency, okay, that is what is the Fourier transform of x of n, x of e power j omega. If this frequency is shifted by some omega naught amount means what is the effect in time domain. Okay, in a reverse we studied, it is said to be the frequency shifting property. Okay, so this is also a very important property. If they are mentioning means time shifting, frequency shifting, convolution, time reversal, these are all the important properties they will ask. Okay, so x of n, the Fourier transform is x of e power j omega means and x of n signal multiplied with e power j omega naught n. What is e power j omega naught n? It is a complex exponential signal. We studied in the first unit in the standard signal. We studied complex exponential signal. If any function, any discrete time signal x of n multiplied with complex exponential signal means the Fourier transform answer is that the original Fourier transform shifted by omega naught amount, that is x of e power j, this omega is shifted by omega naught amount, omega minus omega naught. Okay, similarly instead of e power j omega naught n, if e power minus j omega naught n is multiplied mean this spectrum is shifted by omega plus omega naught. Okay, so that is also one of the frequency shifting property. Okay, so now we are going to prove this property. So the same thing. So in order to prove this property, first we are going to take the DTFT formula. So the Fourier transform, that is a DTFT only I am writing Fourier transform. Okay, simply. So the Fourier transform of x of n as summation x of n e power minus j omega n. So now what is our aim? Our aim is to calculate the Fourier transform of x of n multiplied with e power j omega naught n. So therefore the Fourier transform of x of n multiplied with e power j omega naught n is equal to summation. So instead of x of n multiplied with e power j omega naught n into, in the formula e power j omega n is there. Okay, so you see, so here the 2 e power is there. So 2 e power, the base is common means we have to add the powers, you know. Okay, so here in the powers you see which one is common, j is common, n is common. So you just take j as a common, n as a common. So how can you write e power j, e power, okay, here minus, okay, I am taking minus as a, minus also common. So e power minus j n as a common. So we can write omega minus omega naught. Okay, so you see this formula. So you just see this formula. What is this formula? So if x of n summation x of n e power minus j omega n means it is a capital X of e power j omega. So here in instead of omega there is an answer omega minus omega naught, does that. Okay, that's why what is this one? So this can be written as capital X of e power j omega minus omega naught. Okay, so that's all. Okay, only one step. Okay, you have to substitute, you have to combine the 2 e powers. So then this answer, you see, if this is the formula means we can write capital X of e power j omega. In the place of omega, instead of omega, what is the term is there? Omega minus omega naught. So that's why this entire answer, it can be written as capital X of e power j omega minus omega naught. That's all. Okay, so we proved. So any signal x of n multiplied with the complex exponential signal e power j omega naught n means the DTFT answer is that the x of e power j omega is shifted by omega naught. Okay, so this is the frequency shifting property. Okay, similarly, x of n multiplied with e power minus j omega naught n means the DTFT answer is that x of e power j omega plus omega naught. Okay, so you see here e power plus means minus omega naught. Okay, the spectrum is shifted to the right side. If the signal multiplied with e power minus j omega naught means the spectrum is shifted to the left side. Okay, omega plus omega naught means the spectrum is shifted to the right side. Okay, so this is the frequency shifting property. Okay, so in the next video we have to solve next properties of the DTFT. Okay, so thanks for watching my channel and keep watching, and please subscribe my channel and share this video to your friends. Thank you.